Welcome back to the channel. Watch the video until the end. Leave a like and subscribe to the channel to support us.
A surprise for science. The JWST has discovered a galaxy similar to our Milky Way in the early universe. It took our galaxy billions of years to become a perfectly formed barred spiral galaxy. If such a harmoniously shaped galaxy appears in the early universe, it is either a miracle or an important indication that something is wrong with the models of previous theories on the development of early galaxies. Perhaps the beginning of our universe was completely different, and we are finally about to discover the truth. How is it possible that a perfect barred spiral galaxy already existed more than 11.6 billion years ago if the universe was supposedly still in its infancy? Scientists have had to investigate this question since the James Webb Space Telescope discovered a perfect barred spiral galaxy with a redshift of 3Z. This redshift means that the galaxy existed more than 11.7 billion years ago. A postdoctoral researcher at the Center for Astrobiology in Madrid, Spain, has tackled the issue and obtained surprising results.
Luca Constantine is an expert in galaxy formation and evolution. The researcher is particularly interested in the physical mechanisms that are responsible for the structural composition of galaxies and the coevolution of central black holes. Galaxies are not simply born in the imaginations of researchers. The first galaxies were wild clusters and hosted population 3 stars. It is said that these protostars were huge, lived for a short time, and were made up of completely different elements compared to later generations of stars. At least, this is what the previous calculations predicted. Researchers have described the beginning of the universe with the Big Bang theory, the models of subsequent dark ages, and the phases of star and galaxy development. But the images from the JWST now tell a different story. The newly discovered galaxy, named JWST 21112, existed as a ready-to-use barred spiral galaxy at a time when the universe was supposed to be only 15% developed. JWST 21112 is simply too perfect.
What many do not know is that the JWST can see back to the Big Bang. The 13.5 billion year range is just 300 million years away from the Big Bang, and in cosmological terms, this is a stone's throw. It is said that the universe was completely dark in the first epochs after the Big Bang. The first stars would only have appeared a few hundred million years after the Big Bang. Therefore, the JWST should be able to see these stars, but so far there is no trace of these early stars. All that the telescope has found so far are galaxies and black holes that seem to already be several billion years old. Scientists are faced with an exciting cosmic thriller. How will it end?
Luca Constantine and his colleagues are contributing to this new adventure in astrophysics.
They have dedicated an entire study to the incredible galaxy JWST 21112 in the article, A Redshifted Spiral Galaxy Similar to the Milky Way at Redshift 3. The mysterious early double of our Milky Way is examined in detail. The phenomenon of JWST 21112 has raised the question of how a star-shaped bar structure could already exist in a seemingly young galaxy. In the current universe, most massive disk galaxies show a bar structure of this type at the center. So far, researchers have hypothesized that bar structures form in galaxies with tranquil, low redshift stellar disks, because in high redshift galaxies, the violent turbulence of gas hinders or delays the formation of bars. Simulations have indicated that in galaxies similar to our Milky Way, bars formed only in the later stages of evolution. But JWST 21112 is very old and shows a perfect bar structure. The stellar mass and bar structure demonstrate that JWST 21112 can be considered a precursor to the Milky Way. The structure and history of mass formation match perfectly, but what does not match is the bar and the high degree of evolution relative to its position in the early universe.
This means that the evolution of matter must have been different from what we previously imagined. According to previous hypotheses, barred spiral galaxies form through the dynamic evolution of spiral galaxies, in which a central bar of stars forms over time.
This process is driven by various dynamic instabilities and interactions within the galaxy. The formation of a bar begins when the gravity within the galaxy causes the stretching and elongation of the orbits of stars in the inner part of the galaxy, creating a stable bar.
This occurs thanks to the autograph for further development of the galaxy.
These processes can subsequently promote the formation of active galactic nuclei or stimulate the formation of stars in the central regions. In further connections, the bar influences the distribution and dynamics of stars and gas in the galaxy disk. It can stimulate the formation of beautiful spiral arms or lead to the formation of particularly impressive arms when the material concentrates at the ends of the bar.
This serves as a starting point for the spiral structure.
The bar can also influence the chemical composition and star formation rate of the galaxy, as it facilitates the transport of gas to the central region, where it then promotes star formation. In recent years, observations and simulations have shown that bar structures are very common in galaxies and play a significant role in explaining the diversity of galaxy shapes and dynamics.
From research, we already knew that bars could form at different stages of galaxy evolution.
It was categorically excluded before that bars were present in galaxies that existed more than 9.3 billion years ago.
So, what is Cheers 21112? A cosmic miracle, or is the galaxy further evidence that our scientists have so far overlooked crucial facts about the evolution of the universe? A galaxy for your birthday. Who doesn't dream of having their own galaxy? For Maisie Finkelstein, this dream came true when her father, an astronomer at the University of Texas at Austin, discovered one of the most curious galaxies in the universe right on her birthday. Finkelstein immediately turned his discovery into a gift for his daughter. And since then, the galaxy with the official catalog name Cheer J11.46 plus 5256 32.8 has been simply called Maisie's Galaxy. This galaxy is one of the earliest galaxies ever observed, just 390 million years after the Big Bang. Maisie's galaxy was already traveling through the universe as a surprisingly advanced galaxy. Stephen Finkelstein and his team are conducting research on decoding the light signals coming from very ancient galaxies. The JWST is a marvel of technology, but it is not capable of showing us very ancient galaxies with the excellent image quality with which we can see the Andromeda Galaxy or other nearby galaxies. The light from Maisie's galaxy has traveled for over 13 billion years through space before reaching us. In Webb's images, we see these light signals as blurry spots. But Webb's sensors can read incredible things from these clusters of light. The rest is up to astronomers like Stephen Finkelstein, who further interpret the results and place them in a scientific context. The JWST has allowed Finkelstein's team to see the galaxy with unprecedented clarity and to determine its age through precise spectroscopic measurements. These measurements have confirmed that Maisie's galaxy is located at a redshift of Z equals 11.4. Making it one of the earliest and most distant objects ever observed. The age of the galaxy named after his daughter is so far only one of the few confirmed by other research groups. However, Finkelstein suspects that in this era of the universe, there were already numerous highly developed galaxies that apparently differ little or nothing in shape and structure from the galaxies of today. As we look at the formation of our Milky Way, let's delve deeper into the mystery of these ancient galaxies. If we want to travel back to the beginning of our Milky Way, we need to go back about 13.6 billion years, just a few hundred million years after the Big Bang. It began with a complex series of phases ranging from the initial condensation of matter to the formation of a spiral galaxy. In the first moments after the Big Bang, the universe was an extremely hot and dense soup of subatomic particles and radiation. As the universe expanded and cooled, it led to the formation of the first atoms in this era of darkness, before the first stars shone. Small fluctuations in the density of matter began to condense under the influence of gravity. These denser regions attracted more matter, giving rise to the first structures of the young universe, the so-called dark matter halos. Within these dark matter halos, baryonic matter, composed of protons, neutrons, and electrons, began to condense under its own gravitational force. These condensations led to the formation of the first stars and star clusters, which were the building blocks of later galaxies. The merging of smaller gas clouds and star clusters under the influence of gravity gradually led to the formation of larger structures. It is said that a galaxy the size of our Milky Way was formed from the merging of several smaller galaxies and gas clouds. At least this is the story so far told. If we follow this approach, the Milky Way was likely an irregular galaxy in the early stages of its development, which only acquired its current spiral structure through further mergers and the accretion of matter.
The central condensation at the heart of the Milky Way and other galaxies is believed to have played a decisive role in shaping the galactic structure. The formation of the Milky Way and other galaxies is closely tied to the development of chemical elements. The earliest stars were composed mainly of hydrogen and helium, elements that were formed shortly after the Big Bang. These stars produced heavier elements through nuclear fusion within them. When they reached the end of their lives, the supernova explosions dispersed these elements into the interstellar medium, enriching the galaxy with the building blocks for new generations of stars, planets, and eventually, life. But the discoveries of the JWST suggest that these calculations might probably be wrong. We have not yet seen any of these early giant stars, nor do we see irregular galaxies in the young universe. This means that science must start over, and either we live in an anomalous universe, or perhaps the universe had no beginning and has always existed perfectly.
In this emerging context, astronomers and cosmologists are reconsidering their theories and models.
The mystery of ancient galaxies, such as Cheers 21112 and Maisie's galaxy, might force a significant revision of our understanding of cosmic evolution. These observations suggest that the process of galaxy formation might have occurred much more rapidly and differently than anticipated by standard models. If so, this would have profound implications not only for cosmology but also for our understanding of the fundamental laws of physics. As scientists work to decipher these puzzles, the JWST continues to provide data that could further revolutionize our way of viewing the universe. Every new image and spectroscopic measurement brings a new perspective, pushing the boundaries of our knowledge ever closer to the very origins of time and space. Faced with such discoveries, we are in a new era of astrophysics, where every discovery could be the key to unlocking the deepest secrets of the universe. As often happens in science, the more we learn, the more we realize how little we know and how much there is still to explore. In this exciting journey, the JWST proves to be an indispensable tool for continuing to peer into the depths of the cosmos, seeking answers to the biggest questions about our existence and the vast universe that surrounds us.